this paper, we will be looking at the Chemistry Paper 2 from the year 2018. Please make sure that you have a ruler, a scientific calculator, and the periodic table to hand. I would also strongly suggest that you print out the paper and have a go for yourself first. In this first question, we are told that crude oil is a mixture of hydrocarbons. The hydrocarbons in crude oil are separated into fractions by fractional distillation, and we have a diagram of the fractional distillation column in figure 1. It says crude oil vapor passes up the column. Complete the sentences using the words below. So in terms of the fractional distillation column, we know that crude oil is first heated, then the hydrocarbon vapours pass into the fractional distillation column. The vapours with the lowest boiling points rise to the top, condense, are cooled and collected. So each fraction condenses at a different level. The next question asks, why do fractions separate? So in a fractional distillation column, the fractions will separate due to them having different boiling points. So the top answer would be the correct answer there. For the next question, it says most of the hydrocarbons in crude oil are alkanes. Figure 2 represents an alkane molecule. Name the alkane. Now, the black particles in the middle here that I'm just colouring in are the carbon atoms. So in terms of naming, it's important for us to know the first parts of the name. If we have an alkane with one carbon atom, then the first part of the name would be meth. If I have a alkane molecule with 2 carbon atoms, the first part of the name would be eth, 3 carbons is prop, and 4 carbons is bute. Therefore, because I have 3 carbon atoms, the first part of the name would be prop, and because it's an alkane, the second part of the name would be ane. So it's propane. Now for the next question, we're told methane has the formula CH4 and is an alkane. What is the general formula for an alkane? So for an alkane, however many carbons you have twice as many hydrogens plus 2. So the correct answer would be the bottom one there. Then we're told alkanes burn in oxygen. Balance the equation for methane burning. Now, one key point for this particular question is, although there are lines in front of every single molecule, it doesn't mean that we have to put a number in every one of those spaces. So let's balance out one element at a time. So if we look at the carbons to start with, we have 1 carbon on the left-hand side and 1 carbon on the right-hand side. So they're balanced. If I look at my hydrogens, I have 4 hydrogens on the left-hand side, but only 2 hydrogens in the H2O. Therefore, I need 2 H2O molecules to balance out my 4 hydrogens on the left-hand side. Then, if I look at my oxygens, I have 2 oxygens on the left-hand side, the reactant side. But if I look at my product side, I have 2 oxygens in the carbon dioxide, and now I have 2 water molecules, so I have 2 oxygens there, totaling 4 oxygens on the product side. So to get 4 oxygens on my reactant side, I would need to put a 2 in front of the O2, and that is now balanced. For the next question, we are told ethene is an alkene. Which reagent is used to test for alkenes? And the correct answer would be bromine water, because if you put bromine water into an alkene, it's a brown orangey coloured liquid to start with, and when you mix it with your alkene and you give it a shake, it turns into a colourless solution. Now for this next question, we're given Table 1, which shows the data from a life cycle assessment for the disposal of 10,000 biodegradable plastic bags. So we're given the mass of carbon dioxide produced, the mass of solid residue produced, and the mass of sulfur dioxide produced for burning the plastic, biodegradable plastic bags, or for putting them into landfills. So the first question is, why are life cycle assessments done? And the answer there is we use them to assess the impact of the product on the environment. Now, for the next part of the question, it says compare the two methods for disposal of biodegradable plastic bags. Use the information from Table 1. Okay, so if we look at Table 1, we can see that burning the biodegradable plastic bags produces 25 kilograms of carbon dioxide, whereas putting them into landfill produces 15 kilograms. If we burn the plastic bags, we're producing 0.05 kilograms of solid residue, whereas if we put them into landfills, we're producing 0.07 kilograms of solid residue. And if we then burn our plastic bags again, we're producing 0.2 kilograms of sulfur dioxide, and putting it into landfills produces 0.3 kilograms of sulfur dioxide. Therefore, we can see that burning produces more carbon dioxide, it produces less solid residue, and it produces less sulfur dioxide. This next question is about the Earth's atmosphere. Carbon dioxide is a greenhouse gas. What is another greenhouse gas? So out of our options, we've got argon, methane, nitrogen, and oxygen. The other greenhouse gas would be methane. Then the next question says, greenhouse gases cause global climate change. Give two effects of global climate change. So we can talk about the global temperature rising would mean that sea levels would rise because we have more melting ice from the ice caps. We can also talk about extreme weather. So we'll put our two answers in there. Now, the next question says that 4.1 kilograms of a plastic is used to make plastic bottles and has a carbon footprint of 6 kilograms of carbon dioxide. Calculate the carbon footprint of one plastic bottle of mass 23.5 grams. So the first thing that I would do to keep everything in the same units, I would change the mass of the one plastic bottle to kilograms. So to do that, I would do 23.5 divided by 1000, and that would change our answer into kilograms, which gives us 0.0235 kilograms. So if 4.1 kilograms of plastic has a carbon footprint of 6.0 kilograms, if I did 6 divided by 4.1, that would tell me what the carbon footprint would be for 1 kilogram. Then what I could do is I could multiply whatever that answer is by the mass of the plastic bottle in kilograms. So that would be 0.0235, and that would tell me the carbon footprint of the one bottle. And if I calculate that out, I get an answer of 0.0344 kilograms. Now, in this next question, it says, give one way that carbon dioxide emissions can be reduced when a plastic bottle is manufactured. So there's two ways here. We can either say that we can use recycled plastic, or we could say we can use less plastic to make the bottle. Now, for the next part of the question, we have a 6-mark question which says, explain how the percentages of nitrogen, oxygen, and carbon dioxide in the Earth's atmosphere today have changed from the Earth's early atmosphere. So we need to make sure that we mention all three gases. So first of all, if we think about nitrogen, Early on, volcanoes used to erupt, which would release nitrogen into the atmosphere. They'd also release carbon dioxide, methane, and ammonia. The ammonia would then be changed into nitrogen, again increasing the percentages of nitrogen. Then, as the temperatures around the world cooled, the water vapour that was in the atmosphere condensed and formed the oceans. The oceans then absorbed carbon dioxide from the atmosphere, and that led to carbonates being formed, which led to sediments. But also, um, we also had algae and plants that started to form. Now, when plants started to form, they would undergo a process called photosynthesis, which takes in carbon dioxide to enable the plants to grow, but would also release oxygen into the atmosphere. So, again, this led to the percentages of carbon dioxide decreasing and the percentages of oxygen increasing due to photosynthesis. In this next question, a student investigates the mass of dissolved solids in 5 centimeters cubed samples of water. So figure 3 shows the apparatus, and we can see the setup below with the Bunsen burner, tripod, water boiling, and we use the steam to evaporate the water from the watch glass, leaving the solid behind. So table 2 shows the students' results, and the 3 types of water used were seawater, river water, and rainwater. So we have the mass of the watch glass, the mass of the watch glass and dissolved solid after the water's been evaporated, and then we have the mass of the dissolved solid of the 5 centimeters cubed of water, and then we're scaling up to find out the amount of dissolved solids in 1,000 centimeters of water. So it says calculate mass X in table 2. So they've scaled up the mass in the seawater and the rainwater, so that we know how much there was in 1,000 centimeters cubed. So what we have to do is we have to figure out what the mass would be for the river water. Now, to work out how much times more 1,000 centimeters cubed is compared to 5 centimeters cubed, if we do 1,000 divided by 5, that gives us 200. So 1,000 is 200 times more than 5 centimeters cubed. Therefore, we would do the mass in 5 centimeters cubed, which is 0.08 grams, times 200, and that gives us an answer of 16 grams. So there would be 16 grams of our solid in the river water with 1,000 centimeters cubed. For this next part of the question, 5 centimeters cubed is a very small volume of water for each experiment. Okay, so give one advantage and one disadvantage of using a larger volume. So one advantage of using a larger volume would be that we'd get more accurate results. The disadvantage, however, would be that it would take longer because we need more energy to make the water evaporate. For the next part of the question, it says potable water is not pure water. Describe the difference between potable water and pure water. So pure water has absolutely no solids dissolved in it whatsoever, whereas potable water does have solids dissolved in it. Now for the next question, it says potable water is obtained from both groundwater and from seawater. Describe how groundwater and seawater are treated to produce potable water. So first of all, groundwater first is filtered to get rid of any debris, any solid debris that's in there, and then it's sterilised, usually using chlorine, whereas seawater, because there's so much salt in it, has to be desalinated, and that's usually done through distillation. For this next part of the question, it says the percentage by mass of dissolved solid in a 6.5 gram sample is 2.2%. Calculate the mass of the dissolved solid. So basically what we need to do is we need to work out 2.2% of 6.5 grams. So we've got 2.2% out of 100% of, so that's times our 6.5 grams. And if we calculate that out, we should get an answer of 0.143 grams. In this next question, we're told that fertilizers are formulations. And the first part of the question is just recall. What is a formulation? So a formulation is just a mixture designed or formulated as a useful product. Now, in the next part of the question, it says a bag of fertilizer contains 14.52 kilograms of ammonium nitrate, and we're given the formula. We're told the relative formula mass of ammonium nitrate is 80. Calculate the number of moles of ammonium nitrate in the bag of a fertilizer. Give your answer in standard form to two significant figures, and that's important, standard form. So first of all, because we're given our mass in kilograms, we need to change it into grams. So 14.52 kilograms is 14,520 grams. So to work out the number of moles, we would do the mass in grams divided by the relative molecular mass, and that gives us the number of moles as 181.5. However, the two things we were told is, first of all, we need to give our answer to two significant figures. So giving this answer to two significant figures would be 180. But then we need to put it into standard form. So putting this into standard form would be 1.8 times 10 to the power of 2. And that is our answer in the correct way based on how the question asks us to represent it. So we would put 1.8 times 10 to the power 2. Now, if we did not convert this at the end and we got to here or here, we would probably lose 1 mark. In the next part of the question, we're told the fertilizer also contains potassium chloride. Explain why potassium chloride has a high melting point, and there's 4 marks for this question. So first of all, because we have a metal bonded to a non-metal, it's important that we realise that the structure here is going to be a giant ionic lattice. So we're going to have lots of strong electrostatic forces between oppositely charged ions, which therefore means lots of energy is needed to overcome this. In this next question, we're told a student investigates the effect of size of marble chips on the rate of reaction between marble chips and hydrochloric acid. This is the method used. So they add 10 grams of marble chips into the flask. Then they add 50 centimeters cubed of hydrochloric acid, connect the gas syringe and start the timer. And then they record the volume of gas produced every 10 seconds. So we're shown our setup, and we're asked for the first question to complete the equation for the reaction. So here we have a metal carbonate plus acid. So we're going to first of all make the salt, which, because we're using hydrochloric acid, would be calcium chloride. We're also going to make carbon dioxide gas, because we're using a carbonate, and water. And then to balance out our equation, we would have to have a 2 in front of the HCl. Now here we're shown a graph, figure 5, showing the students' results. It says describe the trend shown in figure 5, and we've got to use values in our answers. So first of all, we would say between 0 and 10 seconds, we have a rapid increase in the volume of gas. And then between 10 to 30 seconds, the volume of gas is still increasing, but not as rapidly. And then after 30 seconds, there is not an increase in volume of gas, which indicates that the reaction has stopped. For this part of the question, it says describe how you would use figure 5 to calculate the rate of reaction at 15 seconds. And it says you do not, and that's highlighted in bold, need to do a calculation. So we've just got to describe how we would do this. So first of all, you would have to draw a tangent on the graph at 15 seconds. And then you would calculate the change in volume divided by the time taken with respect to the tangent. Then we've got to give the units for the rate of this reaction. So because we're doing volume is centimetres cubed divided by time taken, which is in seconds. Our unit is centimetres cubed per second. Then we have a table of results of an investigation which was done with different sized marble chips. So we had small, medium, and large, and the volume of gas that's produced at different time intervals for each. And then the question is, give one conclusion about how the size of marble chips affects the rate of reaction. So if we take any one of these times, so let's take 10 seconds as an example, we can see that in 10 seconds, the small marble chips produce 35 centimetres cubed of the gas, medium produced 21, and the large only produced 14. So this is showing that the small marble chips produced most gas at the same time interval. So what this is indicating is the rate of reaction increases as the marble chips get smaller. Then for the next question, it says suggest why all three sizes of marble chips produce a maximum of 60 centimetres cubed of gas. So they'll produce the same volume of gas if you have the same mass of marble chips to start with. Now for this question, we have figure 6, which shows 8 small cubes, each of 1 centimetre by 1 centimetre by 1 centimetre, and one large cube, which is 2 centimetres by 2 centimetres by 2 centimetres. So we're told the total volume of the small cubes is 8 centimetres cubed. We're told the total surface area is 48 centimetres squared. And for the large cube, we're told the volume is 8 centimetres cubed, and we're asked to calculate the surface area of the large cube. So if the large cube is 2 centimetres by 2 centimetres by 2 centimetres, to work out the area of one side, we would do 2 times 2, which is 4 centimetres, 4 centimetres squared. And if one side of the cube is 4 centimetres squared, we have 6 sides to our cube. So we would do 6 times 4, and that would give us 24 centimetres squared. So our answer here would be 24. Then the next part of the question says, explain why the size of the marble chips affects the rate of reaction and give your answer in terms of the collision theory. So based on the collision theory, we know that smaller chips have a much larger surface area. And because they have a much larger surface area, that means that more of the liquid or solution around it would be able to collide with more of the surface, so we would have more frequent collisions. So in this next question, it says the student repeated the investigation with small marble chips using hydrochloric acid with a lower concentration. And figure 7 shows the volume of gas produced during the first 40 seconds. Explain why the results for the lower concentration of acid are different from the results of the higher concentration. So, first of all, we can see that the lower concentration, the graph is less steep than the higher concentration, and this is because there's going to be less frequent collisions, because at a lower concentration there's fewer particles in the same volume, so there's not going to be as many collisions occurring. For this next question, it says bleach is a solution of sodium hypochlorite, and we're given the formula NaClO. Chlorine gas is produced when bleach reacts with hydrochloric acid. So sodium hypochlorite plus hydrochloric acid is in equilibrium with sodium chloride, water, and chlorine gas. So the first question is give the test and result for chlorine gas. So the test is that we hold some damp litmus paper near the chlorine, and if the chlorine bleaches it white, then it proves that it's chlorine gas. Then for the next part of the question, we are told that figure 8 shows a sealed flask of sodium hypochlorite and hydrochloric acid at equilibrium. And we have our diagram here. The question is, it's 2 marks, explain why equilibrium is reached in this reaction. So, because we have a closed system and no gases can escape, what this means is that for it to reach equilibrium, the forward reaction has to equal the backwards reaction. So in this part of the question, we're told that the stopper in figure 8 is removed and hydrochloric acid is added. The stopper is replaced. Explain what happens to the equilibrium. So according to Le Chatelier's principle, the system will try to counteract what we do to it. So if we're adding extra reactants, the equilibrium will shift towards the right-hand side to use up the extra reactants that have been added. And this will happen until a new equilibrium is reached. So now we are told that chlorine gas is also produced when hydrogen chloride decomposes. So hydrochloric acid is in equilibrium with hydrogen gas and chlorine gas. The forward reaction is endothermic. Predict the effect of increasing the temperature on the amount of chlorine gas produced at equilibrium. And we've got to use Le Chatelier's principle to predict what's going to happen. So, first of all, if we're increasing the temperature, the equilibrium is going to try and counteract the increase in temperature. So, it's going to try and take in the extra heat energy that we're giving to the system. And that is an endothermic reaction. So, the equilibrium will shift towards the right-hand side where it produces more chlorine gas. Now, for the next part of the question, it says explain the effect of increasing the pressure on the equilibrium. Now, the pressure is down to the number of moles of gas on either side of the equilibrium. So if we look on the reactant side, we have 2 moles of gas. If we look on the product side, we've got 1 mole of hydrogen plus 1 mole of chlorine. So we also have 2 moles of gas. So because the number of moles of gas is the same on both sides of the equilibrium, increasing or decreasing the pressure will not impact the equilibrium. So well done, we've come to the end of the session and we've been through a whole past paper explained. If you would like access to more of this type of learning for chemistry, biology and physics, please hit the subscribe button and the notification button. There are past papers on there already, but I will be adding more frequently.